Good evening, everyone, or afternoon, morning, wherever you may be. I'm Cairo, for those of you who don't know me, and I'm here to talk about visual tools for artists in Unreal Engine, as Tim said. Um, Environment art is a career that requires us to know and understand a lot of different skills and softwares in order to do our work. It's sadly not enough anymore to just be able to model and texture assets nowadays. There's the sort of expectation to make your work stand out from the crowd. So you need to make sure that it's also well presented. You need to show that you have an understanding of lighting, composition, and also to a certain degree the technical side of your game engine, whatever that may be. So this talk is going to focus on the tools that aren't necessarily needed to land you a job as an environment artist, or like won't be part of your everyday workflow, but will help add some visual interest to your scenes or help speed up your workflow so that we can all focus on what is at the end of the day the most important thing, which is of course the art. These are various tips and tricks I've picked up and collected over a couple of years of using Unreal, and they help me with very quickly populating scenes and playing around with look dev, so I hope they will be helpful to you as they have been to me. Tim already did a very good introduction from me, but just a quick one. My name is Cairo. As I said, I'm an environment artist working at Cloud Imperium Games in the UK. I've been in the industry for nearly 3 years now. I started in the outsource industry, working alongside studios like 2K, Playside, Ebb Software, and Ghost Story Games, on a number of projects before moving over to CIG. I'm also currently a mentor for Vertex School and Limit Break, which are both organizations focused on the education of game art and its students, and I'm very passionate about helping those who want to get into the industries, as I know the path for some can be quite complicated with quite a few obstacles along the way, as it was for me. So if you ever have any questions, whether it's related to this workshop or otherwise, please feel free to reach out. I'd like to consider myself easy to speak to most of the time, and I'm willing to do my best to help. So, without any further ado, let's get into the workshop. I just need to get to the right slide. So, as Tim said, I'm going to be breaking this up into 4 different tools that I've been using recently inside the scene in Unreal, and I'm going to go through how they work and break them down very quickly so that anyone could implement them if they wanted to. So, this is the scene that I've created for this workshop, and it's using lots of the different tools that I'm going to be demonstrating today. Some might be a bit more obvious than others, but that's the point of a good tool. Like, at the end of the day, if you can't really tell that it's doing its job sometimes, I think that's best. So the first thing we're going to go over, as the slideshow says, is the time of day preset blueprint. So I know that when I'm working inside Unreal, I like to have multiple different lighting scenarios for my scenes, and it's often quite a pain to have to go in and adjust your directional light angle and its intensity and its color, your skylight, your fog, and all those different combination of actors that make up the look and feel of the lighting. And also having to remember, where did I place that directional light? What intensity was it at? So I created a blueprint that has these presets set up which do exactly that. So this is my BP lighting control. And as you can see on the side over here, I have various different options that allow me to play around with the look of the scene, such as the sun angle, as well as different presets. So currently it's on the daylight preset. However, if I change this over to sunset, the lighting changes. And this is also something that Lumen inside Unreal Engine 5 is really nice to have, because you get these instantaneous lighting changes that don't need to be baked or anything. So it's really cool to have this sort of flexibility with software nowadays. So I have a sunset preset, I have a night preset, which also activates some different lights around the city in the background. Then I also have this one which I like to call the sandstorm or whatever, and you can see that there's a noticeable increase in the volumetric fog as well. So yeah, basically that is the point of the blueprint. I also have options for custom rotation. So if I enable this, you can see that my lighting angle changes quite a bit, and then I can just rotate this 360 degrees, and that applies to all the different presets. So very quick for look dev, and it just really helps me get a look and feel for what I'm going for. So we can hop into that blueprint, and I'll very quickly break down how that works. So essentially all the blueprint has inside is your 5 basic components, which make up your components of lighting and the sky essentially. So we have a directional light for your sunlight. We have a skylight for more sort of ambient lighting. We have an exponential height fog so that I can enable volumetric fog inside the scene and have that as well for other effects. And then also a sky atmosphere, which is what most of the presets here are using. It's just Unreal's sort of default sky system. So you can see it in a couple of the examples here. Actually might not be using it for night. But to counter that, Unreal's just stolen my window. Give it 1 second. There it is. Then we also have a skybox, so that if I want to have a sky that doesn't sort of look like the default volumetric clouds or sky atmosphere of Unreal, I can also have something like that. So for example, the sunset is using a skybox. Just go out of the camera here and you can see over there. So this blueprint just allows me to toggle that skybox on and off, so I have that freedom of, expression to choose what I want the background to look like. I believe night might also be using, yeah, that one's also using a skybox. So those are the basic components of it. And then for most of the tools I'm going to be showing today, they don't really make use of the event graph, because the event graph for blueprints is sort of for more, game mode stuff when it's sort of playing in editor or anything like that. Most of these are going to be relying on construction scripts, because that is what is needed for all of this editor functionality over here. So just to go through this a little bit, it's quite simple how I like to set up my blueprints. I like to set up a lot of sub functions, as you can see on the left over here, just so that everything's neat and tidy. And if I ever come back to it, I know where everything is. So all this blueprint is doing is setting up a very simple toggle system, like you've seen me demonstrate. So it just does a basic check with this branch node saying, is it daylight? Is daylight checked? If that's true, set the daylight conditions. If that's false, is it sunset? If that's true, go ahead and do that. And it just carries on down this chain, looking for something that is set to true, a boolean, a true or a false statement. And as soon as that hits yes, it's going to execute that sub function for all of the different lighting conditions. And then that chain is going to carry on over here inside the branch. And then I just have another sub function for the simple custom rotation, which I've set over here. So in case anyone is not super familiar with blueprints, it involves a lot of variables that you can set for yourself, and you can also expose them so that they're editable for the user outside of the blueprint itself. So that's how we get these sort of things over here. So I have various different variables for angle and for the presets. So if I click on daylight over here, you can see that the details pop up, and then we just have a default value set to true. So this just means that the default value of daylight, because it is a boolean, it's just going to either be true or false. You can see that by default, daylight is my default blueprint over there. Then for the light rotation, yaw, I believe it's pronounced. I never know if I'm pronouncing that correctly. That's inside my set custom yaw function. So you want to be able to edit this outside the blueprint, as I said. So instead of having a generic float over here, you plug inside your variable so that can be affected. The reason why in this instance with this blueprint, I'm only editing the Z value is because I like to have sort of physically accurate quote unquote values for the lighting. So if I demonstrate quickly, obviously if I go into sunset, the light angle is a lot lower. And if you go into daylight, it's a lot higher, sort of like a midday sun. So there are sort of physically accurate values for at what point the sun angle becomes sunset versus when it becomes day. This is also defined inside the sky atmosphere itself. So I wanted to keep those angles for daylight and sunsets and the rest all as consistent as possible and just worry about the Z rotation. So just to break down this sub function, first of all, the custom rotation, all it's doing is you set up a name for your custom function and then it sort of runs along according to the chain. And then you just have a very simple set relative rotation node. You tell it what component of the blueprint to look for, and you plug that into the target. And now it's looking for a rotation to set that component to. So you get the world rotation, which has been defined in our other subfunctions, and then you plug it into the relative rotation with your variable of the light rotation yaw being plugged in over here. You also have other options like sweep and teleport, which I don't really worry about too much because those are sort of more movement based. So all of the sub functions for the blueprints for the presets, they are pretty much the same thing each time around, just with different values. So it's broken down into 4 or 5 different sections here, which make up the light. So that's the skylight, the intensity and the color, the directional light, the intensity, and the temperature, which I prefer to use over color when it comes to directional light, and then also the rotation. Now, the rotation, let me see if I can zoom in further here. The rotation is just sort of values that I've gained by playing around with it in my scene and just, editing this blueprint and coming back and playing with around until I found values that worked for the presets. So for example, this is the Z rotation that can be changed if we wanted to with the other variable. These are values that are both like physically accurate for the type of light that we want and, just work. Then there's the fog, which is obviously going to play a huge role in the scene, depending on what you're using it for or what the lighting or weather conditions may be. So, for example, you can see that there's not much very visible fog inside the scene with the daylight preset, but as soon as you go into sandstorm, you can see that this is going to be, very heavy God rays. I can actually also turn these lights off if we want to get more of that effect. So that's another component. I like to play around with the density and also the fog height fall off, which sort of affects the height of the volumetric fog. So if I were to go to my sandstorm one over here, then I'm just going to drag the blueprint to the other screen and change the height fall off value. So say if I change it to something like 1 and compile my blueprint, you're not going to see too much difference because of how foggy it is. But if I change it to 0.2, which is the default, it's kind of hard to see on the screen at the moment because of how heavily fogged the scene is, but it does add some further distance fog and also higher up. I can also go crazy with the values, like set this to 5 for the density. And am I in the right preset? Just make sure I am. Yeah. Okay, cool. So that's how I like to play around with things. It's a little bit less flexible in terms of setting values and seeing an instant change. You do have to go inside the blueprint and let those changes compile. But then at least for each preset, you are able to have that value fixed and you don't need to remember it for later or anything like that. So then the last component is the visibility of the skybox. So this is pretty simple as well. You just take the skybox component, you can drag this out while holding control, and then you'll get that attribute, and then you can just drag off of this and set the visibility of it. So for each different preset, I want to define whether it is visible or not. So in this case, with the sandstorm, it is not visible. But if I was to go into sunset and go back over here, you can see that it is visible. And when it is visible, there are also certain other nodes that I also want to run after that so that I can affect how that looks. So the skybox for the sunset material is different to the skybox for the night material. So you can see the night is sort of this cloudy, moonlit sky, and the sunset is this more sort of orange color. So using the set material node here, you can switch between materials that are going to be applied to your skybox so that you can affect the look per preset. And then I also found that, if you just want to play around with the scale of the skybox to affect the size of the clouds or anything like that, you can also set the relative scale in 3D for the skybox. So that is pretty much it for the time of day presets. Like I said, it's quite simple, but I think it's very effective for look deving and setting a sort of visual target. So if I was to go into my maps folder over here, so I have a time of day level over here, which I'm going to switch into unlit mode briefly. And there's like some cubes and stuff I've set up over here, as well as a post-process volume. But for the most part, there's nothing else inside the scene. So if you were to take the blueprint, the lighting base, and you drag this in, you've already got a very good idea of what your scene is going to look like. And you can also edit all of the different presets just as you did inside your other scene without having to set up, directional lights, skylights, all of that. So I do like to make the tools that I make very much sort of plug and play as much as possible so that they can work inside any different map or wherever you'd like them to be. So yeah, that is pretty much it for the time of day preset. I'm just gonna quickly go back into the other map. And then I'll look at some questions from the chat if there are any. Okay, so Sia asks, are these presets available out of the box, or do you edit any of these blueprints? I'm not too sure if the question's asking if these are out of the box from Unreal, or if they were made by me. In which case, just to answer both of those, this is not from Unreal at all. Like, this is completely made by myself. So you do have the components from Unreal side, but I've just combined them all into this one handy blueprint so that they can all be accessible at the same time. And also because if you want to be able to change values via blueprints, they need to be inside the blueprints. Otherwise, you have to cast to other blueprints, and then it gets a little bit more complicated. So having all the lighting components inside your blueprints is going to help you call to their different attributes and change them as you want. So Timothy asks, is this something you use between projects? How do you transfer the references to the skyboxes, etc.? So this is something that I've only very recently made. However, it is something I do want to use in other projects now because I think it's very useful. So what I would do probably is search for this blueprint inside the scene, and then probably just try and migrate it over. So if I save this, then it's going to give me a list of all the references that are inside said blueprint. So you can see that the skybox and its materials do show up over here, as well as the textures and everything. So yeah, there are some things I probably cut out of here, like the default sky levels that I have. But yeah, in terms of moving this to another project, it should be fairly straightforward. If you wanted to add new materials or anything like that, it should just be as simple as going into the blueprints and changing that. Sorry, Unreal froze. So if you want to change the references that skybox is alluding to, then you just need to go into this material over here, drop down, and just select the ones that you want to migrate over. Cool. Yeah, so I hope that answers both of your questions. If not, let me know, and then I can move on to the next tool. So the next thing that we're going to be walking through is interactable, as I like to call them, blueprints, which are sort of just dynamic blueprints that create instances inside the blueprint as opposed to out of them. So let me explain what I mean by that. So I have this light thing generator over here. So I have the option to turn on the front lights or the back lights. And this also affects the emissive values of this trim sheet that I have over here, or rather this POM sheet. So this both turns on the light as well as affects the material values of this. But you'll notice that even though the material has changed for this, the emissive has gotten brighter, it hasn't gotten brighter on this doohickey over here, which is using the exact same material instance. Not until I turn on those various settings. So it's really handy to have something like that. So let me show you the common pitfall that I've often run into. So let's say you're using an emissive material for something. So it can be very simple. Let's just go into unlit, make this white, and then multiply it by a scalar, which we'll just name intensity. So this will give you a very basic unlit emissive material. So now the problem with material instances is that you're going to need to have a lot of them if you want a lot of different values. So if I were to drag something like sphere in here, we'll make a material instance of this with the emissive set to 1 and apply that. Let's actually change this to something like 10 so we can have a good idea. And then we're going to make another instance, apply it over here, and we're going to set this to 50. So it might not make too much of a difference if you just have like 2 different lighting intensity values on your POM sheets or your emissive values or whatever the case may be. But over the course of a project, as you have like multiple different scenes and environments and maybe even different levels to transition between, eventually you're going to have like 50 of these instances or colors, as Scott says in the chat. So it's much easier to make a dynamic material instance inside a blueprint and be able to change it that way. So that is what I'm going to demonstrate. So we have my light over here, which consists of the mesh itself and then the rectangular lights, which are actual physical lights, not just light based from the emissive texture. And then I also have this spinny thing, which is just rotating about, which I can also change the speed of with this blueprint. So again, it's all about using the components inside the blueprint that you have and then altering them with variables. Once again, nothing inside the event graph because this doesn't do anything inside game. It's just more for artist control outside of the outside of game, but inside the editor. So this is quite similar to what I was doing with the sky presets. So you want to be able to set the lights on or off for both of these. And I also decided to split these into two different light sections. So light 1 is just going to be these front two. And then if you just want light 2 on, it's just going to be that one. So you can just toggle those independently. But I mean, in all reality, it's more likely that this is probably going to be all turned on at once, but I just wanted to change some lighting values inside the scene. So when setting the visibility, you just need to give it a target so it knows which rectangular light to action. And then after the visibility is set based on that Boolean tick box, then you're also going to set the intensity and the temperature, both of which I wanted to control outside of this blueprint as well. So if I click on this and turn both lights on, you can see that I have a light intensity of 55,000. The reason it's so high is because it's a movable light, and those tend to need a little bit more, value to them, as opposed to static stuff, which you can normally go more physically based with. But what I've done is I've linked the light intensity from the physical light to the emissive value of the trim sheet. So if I were to change this to a much lower value of, let's say, 5,000, you can see that the light dims, but also the value of the material. So if I change that back, you can see that both are now adapting to each other at the same time. You can also implement color into this, but as I said, I prefer to work with temperature when it comes to lights, and there isn't yet quite or at least that I've seen or know about, there isn't a direct correlation between temperature and color that I could find. So I have it set to 12,500 kelvins for this temperature, but you can also change it to a red at 0, sort of like a neutral white at 5,000 or 6,500. So if you were wanting to work with colored lights as opposed to temperature lights, you could also very easily link the colors between those two. In fact, I might just demonstrate how to do that as well. So let me show you how you set up dynamic material instances so that you can edit the values inside of blueprints instead of having to create another instance. So these were for the physical lights, the light activation section, and this is going to be for the material. So this, we only want it to work if the light is on. So that's another way that we can make use of our Booleans. We can check that those conditions are fulfilled before we try any extra functionality. So you can see that if the light is on, it will create these dynamic material instances. If not, it won't do anything, which is exactly what we want. So first, what you need to do is you need to grab the mesh from your components, which is using the emissive material that you want. So we're just going to grab the street lamp, and then you're going to create a dynamic material instance from it. Now, the element index is what slot on the mesh it's going to look for the material in and what values it's going to try and change. So if I go to the mesh for this, you can see that it has a bunch of different material elements because I made this with, trim sheets and POM sheets. So it's got a few different things. So trim secondary, trim tertiary, decals, graphics. So I know that the emissive values I want to edit are inside element 4, which is the decals, which looks something like this. So you can see we have the emissive color here. But we don't want to change them inside the instance. We want to change them inside the blueprint. So this is how we go about it. So you just have to look for the element index that your material is in this case 4, and just select it over here. You just also have to select the material that it's using. In my case, it's that decal mesh sheet. And you can give it an optional name as well, but I don't really find the need. So all that is doing is inside the blueprint is creating a dynamic material instance which is stored inside the blueprint. It's not going to be accessible anywhere else, but that's fine because we don't really want it to be. we haven't yet changed the emissive value. So what you need to do is you need to set the scalar parameter value, making sure that the target is this dynamic material instance. If you set the target to something else like the instance itself inside the editor, this isn't going to work because you need to reference the dynamic one. It's also very important to note that the parameter name over here needs to match what you have inside your blueprint, because otherwise it's not going to work. Because you've told it what mesh it needs to look at, what material, and what slot inside that mesh it is, what material ID it needs to be. So now we just need to give it the parameter name. So if I were to open that up again and open up the decal mesh, you need to make sure it just matches that scalar parameter name of emissive intensity, just so it knows what to look for. And then the value, as I said, is in correlation to the physical light value. So I was playing around with the sort of multiple that would make them match between the value of the light and the value of the material. So I found that dividing 55,000 by 220, give or take, more or less gives me the brightness in the material that I want. So just to go into a little bit of extra detail about how you can use dynamic material instances, we also have this spinning element that I wanted to add to this. It's nice to have a little bit of movement to the scene. That's why I was playing around a lot with the volumetric fog and elements on the machinery like this. So this is actually being spun via the material instance. So I can actually open up that material quickly. So go to spinny. And you'll see that if I click on the material instance inside the blueprint, you can see it says material instance dynamic. So that is being stored somewhere. So what I need to do is actually find the one over here. So the reason why mainly I wanted this to rotate in engine is because, or rather in editor, is because, I didn't want to have to worry about rotating anything with a blueprint, or although you can do it that way as well. It's just quite nice, and I think a little bit cheaper to just have things spinning via the material editor. So this is just a world position offset that is rotating around the pivot of this mesh. You will notice there is a little bit of artifacting going on. I'm not too sure at the moment if that is like a lumen discompatibility with world position offset at the moment, but as soon as you zoom out a little bit, it's not really making much of a difference. So this is the area of interest over here. We'll just call this rotate about axis. So this is how you can make your meshes spin or rotate without having to, sequencer them or keyframe them or anything like that. So you use the rotate about axis node plugged into the world position offset, and then you just need to give it these inputs that will define its rotation and position. So the absolute world position, it's going to look at where the specific instance of this mesh is placed inside the scene. So because we have multiple of these, it needs to know the absolute world position of each in order to work out where the pivot is. As for the pivot point, we're going to just use straight up the object pivot point node, and just that is going to be plugged in. The rotation angle, because we want it to change over time and rotate, we're going to multiply it by time as input data. So I have speed here set to 0.1 as a default value, but as I said, that doesn't really matter because we're changing it through the dynamic material instance inside the blueprint. As for the normalized rotation axis, this just determines which axis of the pivot it's going to rotate about. So in this case, I want it to rotate around the z-axis because it's going to rotate around this column. So z-axis is blue. So this would be x, this is y, and this is z. So to get away from the materials for a bit and show you how this is linked to the dynamic material instance, pretty much exactly the same setup as for the emissive material. We're going to create a dynamic material instance and going to set a scalar parameter value. It's also worth noting that you can also set, other parameters for the material instance. It's just a case of going through all of those and just seeing what works for you. It's not always going to be a scalar value. So then we have a rotator speed float variable, which has been exposed to the editor. So now we can go in and we can set the speed of the rotator. So I had it set to 0.05, but if we set it to 1, you can see that is going to rotate quite quickly. We can even change the direction of it by making it negative. So let's make this negative 50, and then that thing is going to be spinning quite a bit. Let's turn this down back down to -1. And then just to demonstrate again the power of the dynamic material instance, we can change this to 5,000. Maybe it's a little bit faulty or it's not shining as brightly as it should. And you can see the effect there. So these are two different blueprints with two different settings, but they are both using the same base material instances without having to go in and change those. So I think that is the power of this method. That is pretty much it for this chapter, so to speak. I see someone's typing in the chat. No? Okay. So I'm gonna carry on with the next section. Next section, if I see any questions pop up. Oh, they have. There we go. Lloyd asks, can you then link the spinny thing up to your time of day things easily? Example, sandstorm, they go wild, or is it hard to link cross blueprints? That's a little bit harder to do. I have sort of implemented that at some stage, but it involves casting from one blueprint to another. So casting is essentially, I'm not going to do it live because I will mess it up probably. But so casting allows one blueprint to read the attributes of another. So if I was inside my lighting blueprint, I could cast to my floodlight blueprint and get the attributes of that. So because we've exposed these variables, such as the rotator speed, then that would become available to us, yes. And then for the different presets, you could then go in, cast to the floodlights in your scene, and then change the rotation speed, which is actually quite a cool idea, and I probably have to do it now. Cool. So I'm gonna go next into some volumetric effects. So I'm just gonna go back to my PowerPoint over here. So I'm going to be going over the volumetric effects in the scene. It is worth noting that the true volumetric effects I have going on over here, you can see I have these sort of fog volumes going on. Let's turn on select transparent. So these are fog volumes that are based on the bounds of this cube that they are placed in. I did not make these. These are from Fluid Ninja, which has recently been released for free on the Epic Marketplace as part of their permanently free collection or whatever it's called. So I didn't make this, but I just thought it would be nice to compare true volumetrics to the sort of faux volumetrics that we're going to get into now. So yeah, if you'd like to download those and open up, they have quite a few settings. Bit of a complicated material because it's using multiple tiling textures and atlases with sequence players to drive the motion of the fog, which is a little bit out of my level of tech experience. But they look cool and they add quite a bit to the scene. The volumetric effects we are going to be focusing on, as I said, the sort of fake volumetric effects are these smoke plumes, which, as you can see when I click on them, are actually just 2D planes with material applied to them. But the difference with this material is that it has a feature called 2D Raymarching applied to it. So you can see my sun angle is coming from off to the right over here, and you get this nice edge highlight on the smoke, which if I were to rotate it, would do a fairly decent job at matching that rotation. So if I were to go over here and change this, you can see how that edge highlight changes as I rotate it. So it's sort of attempting to mimic the diffusion of light through smoke. So if I open up this material instance over here, you can play around with a lot of the values. Let me go this. So all these large smoke plumes are using that inside the scene. Let me just change these back. It's a little bit distracting. And if I were to play around with the material instance of this, you can affect the contrast up to something really heavy like that, or you can make it sort of non-contrasty at all. You can affect the depth fade of this. So in order to get this to blend nicely with the rest of your scene, if it's sort of visible, you want a depth fade so that it's not such a harsh transition between the smoke and the ground. So if I bump that up, the more I bump that, the better transition you're going to get. So this is just helpful if you want this in the foreground, just to have a bit of a more convincing effect. Then you can also affect other settings, which we're going to get into when we play around with the material instance. But then probably the more interesting one you can play around with is the light color. So unfortunately, the material instance itself cannot feed or cannot look into the rest of the world and see what color the sun is set to. So you sort of do have to set that by hand. However, if you set it to almost a sort of natural whitish color, it should change fairly well no matter what your lighting conditions are. You can see how it's not the same look as when we were in the day. And if I would go to sunset, you can see that even more here. So it is definitely affected by the light color. So what I can do is I can go into this material and we can just break this down quickly. So this is a little bit different to the blueprint in that, you know, it's a material obviously, but I think stuff like volumetrics and, you know, lens flares and all of this extra stuff, which isn't necessarily the job of an environment artist to make. This is probably something more like a VFX artist would deal with. I think they do add so much to environments, and it really helps with the mood and everything else, which is really what is going to sell your assets. So, as I said, this material uses a technique called 2D Raymarching. Now, I'm not going to pretend to know all of the ins and outs of this. As I understand it, it's sort of the big brother to ray tracing, in that it's going to take the direction of light rays inside your scene, in this case the directional light, similar to ray tracing again, and then it's going to attempt to simulate bounces and depth to it. So what I can do is, if I go inside my instance and I'm just going to drag it over here, you'll see I have an instance, or rather a parameter called march distance, which if I set it to 0, it's basically setting your ray marching steps to 0 so that no light bounces are being simulated. However, you can bump that up to higher values, and the higher you make it, the more light is going to simulate diffusion inside your smoke plume. So just for a sort of art direction sense, I like to have it at about 0.5 so that you get a nice edge highlight on them. And then you also have a number of steps. This is sort of similar to how parallax occlusion mapping works, where the more steps you take, the more accurately it's going to render. So you can see if I bump it down to 1, it's not really doing anything at all. And as I go up to successive numbers, it gets more and more accurate, so to speak, with the Raymarching. But at a certain point, it's diminishing returns in terms of, you know, how it looks. So I'd say there's not much difference between 6 and 7. So that's where I kept it for performance reasons. Just before I continue, if you are interested in making your own volumetric fog material for a true 3D volumetric fog, like the Fluid Ninja examples have shown, I recommend following Chris Murphy. I believe he works at Epic. Following him on Twitter, he has a volumetric fog tutorial that breaks down the entire material, and it allows you to apply that volumetric material to any shape, and then it allows you to sort of artistically place it around your scene, like has been done with the Fluid Ninja example over here. Obviously, the Fluid Ninja example is a lot more, complex with the animation and the movement, but the tutorial by Chris, I think, really explains it really nicely. Also, if you are interested in learning a bit more about 2D Raymarching from someone who knows what they're talking about, I found this really cool video by The Art of Code on YouTube, and they explain Raymarching in games, where it's been used, popular examples, and stuff like that. Much better than I could, so definitely give that a watch if you are interested about it. But, I will do my best to explain as best I can. So we're going to break down this material step by step and hopefully, enable someone to remake it if need be. So the majority of the material is fairly simple. I'd say there's some more complex stuff in terms of fading out the edges of the smoke. But for the most part, it's just a bunch of textures with panners on them to simulate smoke rising or moving. So the only real difference is the 2D Raymarching, which really only affects the base color, so it's not even, a very expensive thing to do. I'm going to quickly detach that from the material and just show you what the difference is. So this is probably more akin to the smoke that you'd see with like default Unreal packs and stuff like that. It's very flat, it's very one-dimensional. It's sort of trying to simulate depth with the color, but it's really not doing enough. So really that light interaction that this 2D Raymarch gives you, I think it's really valuable. Okay, so let's break this down. So it's also worth noting that this is also material that I've found and also sort of changed for my own purposes. So there are things that are not quite as how I found them. So most of these textures were, I believe, created procedurally, and they are just a bunch of different smoke textures that are sort of blended together for this purpose. So you have a generic tiling smoke, which is used for the center. You have a smoke with an edge alpha for as it fades out near the top. And you also have a generic dissolve texture, which is how we get probably not the best place to show it. That's how we get the smoke sort of fading out at the top over here and not ending in a sharp, jagged line. Those are the textures we have. We also have a vertical smoke, because this is just essentially a couple of textures mapped to a straight plane, and then, mapped, UV mapped straight. So it's nothing complex on the mesh side of things. So let's dive into how this is animated a little bit. So first of all, we are plugging a texture coordinate node into a panner. And the reason why we're using this is so that we can scale the UVs of this texture. If you look inside the viewport over here, you can see that this is slightly stretched in the V direction. That's because of this change in scale over here. If I were to change that back to 1, it would, well, it should change it back to 1 over there, but it's probably just not updating the preview. So you plug that into the coordinates. As for the time, if you leave that by default, it'll just use game time. And then speed has been changed over here. You can also expose the parameters for speed. So for example, you wanted a speed X and you wanted a speed Y, so that you could change that. Then you would append these two. and you could plug that into speed. So if we were to take the values that they used over here, 0 for X, obviously, because you don't want your smoke going from side to side, and 0.1 for Y. So let's set that as the default value. Apply that. Then now if I go into this and give you a clear view of the smoke again, you can now see that the center smoke only is rising at a different rate. And that sort of gives you an idea of how many different textures this the smoke is made up of. So let's set that back to default. You can now also make it go in the X a little bit because, I mean, I suppose that might be nice because of some directional effects. You might also want it to go in the direction of the planes. That could be useful if you set it at maybe a bit more subtle value. So that's the sort of basics of how they are getting this to work. So this is linearly interpolated between the center and the edges. So how they get the top to fade out is pretty much the same example over here. If I were to preview this, this is just a tiling texture scrolling upwards in 2D space. But then what they're doing is they are adding this to the UV coordinates in order to make it fade out. So if I were to preview this texture, and let's put it on a box, you can see how at the top over there, due to the UVs being distorted by this texture, it sort of gives you that natural fall off and fade out of the smoke. So what's happening here is these are the default UV coordinates, sort of like how they were plugged into here. The tiling hasn't been changed over here. The only difference is we're using a constant bias scale. So I hope I don't butcher this explanation, but what a constant bias scale does is it has two values. It has a bias and has a scale. So it's very useful for remapping values. So for example, if I have, just going to draw over here, say if I have something of a range of -1 to 1, let's say, and I want to remap that to 0 to 1, which in the case of most textures is what you want to do because we are normally working with black and white values, which are represented as zeros and ones. So the bias is sort of an addition. So in this case, if we want to get to 0, 1, we would set the bias as 1. And then what this is going to do is it's going to shift the values up 1. So it will now be 0 and 2. So we're sort of halfway there, but now our upper bound is too high. So then the scale is just going to act as a multiplier. So we're going to then end up with from 0 to 2, multiply both by 0.5, and that's going to give you 0 to 1. So that is pretty much what is happening over here. There's a negative bias of negative 0.5 and a scale of 0.1. So you can see here we've got quite a lot of gray / slightly lighter values, whereas after the bias is applied, you get something like this. So it's isolated sort of, I'd guess, at around a 0 to 0.2 range, because you only want to add a little bit of deformation to your UVs. So this is what your UVs now look like after adding them to. By default, they will look something like this. Obviously not moving because they've not been affected by the panner yet. And this just represents the 0 to 1 scale in both directions. After adding the constant bias scale, as I said, you get this. So that's a very quick and easy way to distort your textures in order to let them fade out a little bit. The natural gradient of this texture also does help. So all that texture is doing, this other one over here, is just adding some distortion as it pans up so that we get that natural fade out effect. A pretty similar technique is used for the edge fade. So you have this vertical smoke texture, which has a tiling texture applied to a panner for it. Constant bioscale is changed, and then pretty similarly, you have both of these are added together with the texture coordinates. Only this time, the UVs themselves have a panner, as well as the fact that this has also changed the tiling. So you now have smoke fading out at the top, and you also have smoke fading out at, sorry, I just need to undo that. You have smoke fading out to the top, and you also have smoke distortion along the edges. So when you multiply those together, you get our sort of final smoke effect. So now this is where Raymarching comes in, because you all saw how it looked without the Raymarching turned on. So let's go through the Raymarching a little bit. So the 2D Raymarching node you will not find inside Unreal Engine. It's actually a custom node, which you can create by just searching custom. And the difference with between a custom node and something like a material function is that the custom node is mainly based around actual code. So if you look at the 2D Raymarching, you can see that we have these lines of code over here. So I'll actually just copy and paste that to a notepad. So, this is already beyond my scope of understanding. Coding is not my friend, but you can see that for a custom node, you have to define variables similar to a blueprint, and then you have to define the relationship between those variables inside your code. So you can see on the input side of my custom node, we have all of these inputs. So that's why I said it's sort of similar to a material function where you have inputs and outputs. So whoever wrote this node, they defined the textures, the march distance, the number of steps, the timeline, I believe it is, the different UVs, the march direction, the light color, and the contrast. So these are all elements that we can now affect. So based on this code, it's now going to warp and distort the UVs based on the light direction. So that is the end result of Raymarching. As I said, I don't very fully understand the ins and outs of the in-betweens, but that is basically how the custom node works. Custom nodes are very useful. They can also be used for other things like Kuwahara filters, I believe they're called, which sort of distort the edges of and the bounds of your meshes to create sort of like a painterly effect. So custom nodes are definitely very useful if you're wanting to get into that. So yeah, as Lloyd said, as soon as we start talking code, the artists are out. So I will not carry on with the code there. So all you basically need to know about this Raymarching node is that it takes our same inputs as the rest of the material. You add your edge alpha and your vertical, and then we have all of these parameters that I was playing around with earlier, like the march distance, which affects how far the light diffuses into the smoke, as well as the number of steps. And then your UVs are going to be taken from this dissolving UV over here for the first one. And then for the second one, it's going to be taken from this dissolving one. However, this one also has a rotator node added to it. So if I were to preview that, you can see how, let's actually preview it over here. It should just be rotated 90 degrees clockwise. So that's all that is doing. March direction is where it gets a little bit interesting. And this is how it sort of taps into the sun a little bit. We use a node called an atmosphere sunlight vector, which is, I believe at the moment, is only going to work with the sky atmosphere and a directional light and sort of default solutions like that. I don't think it'll work with anything custom like your true skies or your ultra dynamic skies, because it needs that default UE4 sun. It's just going to take that from world space to tangent space, because that's the space that we need to work in for the textures. And this whole result of this 2D Raymarching, we're just going to add this to our center column over here. So if you preview this, this is our final texture without Raymarching. And then with Raymarching, you can see that it's sort of affected by the sun in this scene over here. As for the final part of our material over here, we had our center smoke and we had our edge smoke slash vertical smoke. And all this is doing is being lerped into the center smoke. So it's going to linearly interpolate between the two. So we have going into A, we have, let me just make sure I'm getting this correct. Into A, we have the light color multiplied by 0. And then in the alpha, we have this mix between op and edge fade. So if I was to preview the result of this lerp, it's probably better to view it on the plane or the mesh itself, but it's just going to give you that edge fade. As well as like additional parameters that I've added myself, it's always nice to be able to affect the intensity of the opacity as well as the depth fade that I mentioned earlier. And then you can also affect the intensity of the color itself as well. So if I play around with some of those settings, you can see how you can really art direct the color, the shape, the size of your fog. Yeah, I think that is pretty much it for the volumetric fog. Let me just quickly go through the UVs of this mesh very quickly. So if I were to show the wireframe for this, it's just a curved plane with a couple of vertices so that you can bend it. And then the UVs are unwrapped straight to this according to the textures. So as you can see, it's just going to map that texture to the plane. Pretty simple stuff. Great. So that is it for the fake volumetric fog. I think it's quite a nice effect to have in your scene, especially because if you want to add any highlights or anything like that, which are often very hard to do without changing the sun direction, you can just, say if I didn't want this edge highlight, I just quickly move that over there. I think that the volumetric fog could probably be improved by being made into a billboard of some sort, so that when you are up close to it, the 2D nature isn't sort of betrayed to you. So these are fine from a distance and as distant objects, but as soon as I sort of come around here and change that angle, it's very clear that it's a 2D effect. So having some sort of billboard where that's plane could always face the camera, I think would be very useful. But yeah, that is volumetric effects, 2D Raymarching explained by someone who doesn't understand it at all. I'll give it a minute or two in the chat if there are any questions on this before I move on to the prop scattering tool. Cool. I don't think there are any questions at the moment. Probably a bit too much code for all us artists. I completely agree. So let me get into the last section now. Get back to where I was. World dressing. Okay, cool. So this is what I find myself doing for the large majority of my time inside my scenes at work or at home. If you've got quite a full, vibrant scene, you've got a lot of props that need to be scattered around. You've got foliage that needs to be placed. You just need quite a lot of clutter depending on what you're working on. So this next blueprint is a prop scattering blueprint that I've worked on to dynamically place props within an area based on the collision of other objects. So as always, better to show rather than talk about it. So you can see that I have these sort of junk piles around the scene, and that was the sort of story that I wanted to tell with this environment, that it was this big sort of mega factory that was pumping out all the smoke and debris and garbage. So the majority of these junk piles are made up of these sort of, little clusters of trash bags with the material that I made on them. This is just so that you can save on performance by not having actual tons of meshes all around your scene. But if I was to just have the trash bags without anything else, it would look rather repetitive and plain. So I also wanted to have lots of props around the scene, like these little crates and metallic objects. But of course, there's a lot of trash in the scene, and I didn't want to have to place them by hand. So that is where the scatter blueprint comes in. And you can see that when I selected that one thing, all of these objects got selected, and this is the scatter blueprint. So if I drag this around, it's doing a line trace for collision inside the scene, and then it's going to base props and place them based on that collision. So if I were to go to the blueprints over here, you can see that we have all these different settings for the blueprint that you can change and play around with. So let me walk you through how this works before we get into the back end. So it's quite nice to have a region where you can tell it, I want props spawned in this area. So you can adjust the spawn region to smaller or bigger, and then it will dynamically place based on this bounding box. You can also adjust the amount of props that you want spawned. So for right now, I have 50, but it can also fairly easily handle something like 200. There will be a little bit of a delay as you make things, more heavy on it. But it does give quite a nice effect when you have quite a bit of clutter. So let's say, for example, I want to see some trash bags sold. So let's set this to 50 and over there. So we also have various parameters that you can play around with, like the size. So if I want to set that to 1, then you also have a max difference size object. So if I want these to vary in scale, let's say I want them to go up to size 5, you can do that if you want to, although it might not be applicable for this scene. There's also the collision size for the box. So in order to speed up the performance of this tool, as you can see, it's fairly quick at calculating. We want to use a box representation of the collision for all of these objects so that it's not too intensive on calculating that. So we have this collision size for the placement. I've also noticed that, how collisions can be in games. If I go to play a collision over here, they are not the most exact things in the world. So it can happen that your objects are sort of going to be placed on top of things instead of inside things, which may not be what you want. In the case where the collision doesn't necessarily correlate with what you see visually. So, for example, this collision is quite out of place with what you can see on screen. So if I were to drag the blueprints over here, you can see how the objects are not really sitting as they should. So I also introduced a Z offset to this, which is currently set to negative 25 centimeters. So without this offset, this is where all of your objects would be placed, because now they're being placed directly on the surface of the collision as opposed to the mesh. So just having the simple Z offset just helps place things where you need them to be, especially since I wanted the props to be scattered sort of inside the rubble and the debris as opposed to on top. Something like that is very helpful. You can also see all the line traces, these red dots appearing as I move it around. So that's also very helpful to debug if something is broken or not. There's also the case of seeds. So if any of you have worked with Substance Designer or Gaia or any sort of procedural generator, really, you'll know that you have seeds which sort of still follow the logic of what you have created, but just in different random locations, positions, values. So say, for example, I've dragged this around my scene. Cool, that looks good, but I have these odd outliers over here. as you might often do, you can change the initial seed to a different value so that it might give you a better result. So let's change this to something like 600, and that'll rearrange everything you have so far. And you can sort of just play around with it until you get something that works. Might just be a case of my spawn region being too large, so if I change that to something like 8, that's already better. It's not a perfect system by any means, as I said, because of the collisions and because of, just it's not really using physics to simulate anything. It's just assigning things to points on surfaces and giving them a random rotation. You will get odd sort of instances like this where gravity really wouldn't allow that to happen. Tim asks, have you tried doing this with sphere collisions and seen any differences? I have not. So inside the blueprint, there are options to change the collision type. So at the moment, it's set to no collision, and it's just going to use a box as a placeholder collision. You can also change it to query or physics, although that greatly increases the calculation times and everything, and especially if you're turning on physics. Now each of these separate meshes now has physics enabled, and they are going to eat at your frames, and they're also going to probably bounce all over because, as we know, physics in games is not often hugely realistic. Cool. Let's walk through this blueprint. So this is probably one of the more complex blueprints that I use. So there is a lot of functionality that I just simply don't use, but I'll walk you through the relevant parts that I find to be useful. So if we go to our viewport, we have a box. This is our box that is the spawn region. So as we shrink or enlarge this box, that is where our meshes are going to be placed. You have to have an empty static mesh inside your blueprint so that we can assign random meshes to it. Oh, I did not even go through this in the blueprint. So the blueprint is made up of an object array. So if I go to the drop down here, you can assign as many different objects into the array as you want. So whatever is inside the array, it's going to pick a random mesh outside of that array and then place it. So I can let's add another 2 over here, and let's add like a big cabinet and something like that. If you want to change the weighting so that they are more plastic crates, for example, you could also do that. But yeah, let me probably stick to smaller stuff so it's easier to see. So you have to have this empty static mesh here so that we can assign it and then add it to an array of objects so that you can select whatever objects you want to go in so that those can be placed. So this is also through the construction script as all the other ones we've done. So I'll walk you through this step by step. We're going to set a scale for the collision. So the target will be our size collision box over here, this tiny one in the center. And then we're going to set the collision size, which, if you look at the blueprint, is defined by an X, Y, and Z value, which can be nice if you have very specific meshes which are longer than they are tall, or if they aren't perfect squares or anything like that. That can be very helpful. But in the case of where you have many objects trying to be placed, it's better, I think, to stay with a consistent value and not play around with it too much. So that is our collision box for each object, and then we also have the spawn region, which we're just going to dynamically change the scale of inside the blueprint. And then we want to define the random rotation of the meshes. So basically what this is going to do is it takes the box, which is our spawn region, it'll get the scale, and then it'll break the scale into X and Y. Then basically it's multiplying this by a large integer, both positive and negative, and then it's going to get a random float in that range in order to define a random angle. We're going to make a vector out of this, and then this will give us the relative transform. So essentially, we are giving the blueprint an array of meshes to scatter, and then it's going to scatter them based on the bounds of your box. So this is where your objects variable comes in, and this is, as you can see, it's a very different type of variable. It's a static mesh, but it's an array variable. So, we have the normal default value over here. Here it has the array elements, which is where you can add your meshes. It's just going to check if that's a valid index, and then it's going to continue. The branch node condition in this case is, do we have an array of objects to place? If not, nothing is going to happen. If we do, we're going to go into a for loop, which if you've ever had to do coding in high school or anything like that, is basically just a process that repeats over and over until it is told to stop. So basically, it's going to say, place this object this many times. So that is what we're defining by the amount. So as I go into my blueprint and I change this to say 100, it's just saying place this many objects this many times. So for every object we have inside our array, it's going to add a static mesh component. That is why we have the blank static mesh component. We don't want to define it inside the blueprint. We'd rather define it outside. So that is what that is doing. And then we're going to start running line traces and overlaps to work out where it needs to be placed. So for each mesh, it's going to get the world location. The collision size is going to determine the extent of that box overlap. And then we also want to set up an interaction with type. So what you can do with this interaction with type is you can tell it to search for different things. So I'll go back to the blueprints over here. Here we have the interaction with type array, and if I were to expand this, you can see that it's set to world static. So that's basically telling it, hey, look for anything in the world that has this tag. So at the moment, it shouldn't place props on anything that isn't world static. So it's not going to take into account foliage. It shouldn't take into account the landscape, I don't think. It's only going to take into account static meshes. But you can, of course, change this index and add another one to change it to world dynamic, pawn, physics body, vehicle, destructible, any of these. So I'm gathering from that, if you want it to be placed on top of physics objects or anything like that, you can also do that. So that is now the spawn region searching for things to place on top of. It's then going to run this branch, which is going to set the location of those. So if it's found something inside the overlap, then it's going to set the location of that mesh. And you'll see that it's not quite clear over here, but if I drag this down, you'll see that the out pin of the set relative location is going back into the box overlap component. So it's going to repeat this process for every mesh. You can see here, we also have the teleport option selected. So it's also going to do that. And then we're going to define the location from the static mesh that we defined earlier. So it's going to take that from the return value, set the relative location, and here's where we introduce accuracy. So the problem with this blueprint is if you set the accuracy to be 0, it's just going to try and place it very specifically and very accurately on the collision box. So it's going to try find the exact point of these vertices or these faces and place them, which is going to take a lot longer than if you give it some leeway. So here is where we can add an accuracy factor so that the calculations take a little bit less time. So you'll see if I change the accuracy over here, at the moment it is set to 1. If I were to change this to 0, you would see that the calculation times would increase almost exponentially. You can see that we get a pretty smooth calculation as this goes on. There's not too much lag, but as soon as I make this lower than 1, which didn't freeze my PC this time. That's good. You can see that it gets a little bit slower because it's trying to more accurately place based on the surface. So introducing a little bit of leeway for that, as I said, might be good if you've got, a ton of these to place and you just want, the quickest possible experience. It would also be possible to convert the components of this array into static meshes afterwards, and then this could be converted to a static mesh as a cluster, which would probably save on performance in that case, instead of having all these blueprints in your scene. But that is not an extent that I've taken it to yet. So let's carry on over here. So now we have the box extent, which tells it where to search for. Now we want a line trace, which is going to tell us what point can it be used at. And I'm sure you've seen that when I've been moving that around. So it's going to get the world location, and it's going to subtract an arbitrary value of 10 units down. So that's going to be defining the start and the end points of the line trace. So I've set the debug type for 1 frame. So you can see if I drag this up, you're going to get a lot of these points. I can actually also set it to persistent. And then you can more clearly visualize the line traces. And I find this useful just to look at the line traces and see if they are matching up with the collision. It might be a case where you might want to make a little bit of a tighter collision so that your props can be placed a little bit more freely. Let me change this back. I know it has a problem with flushing persistent debug lines. Let me just flush those. There we go. So that first line trace is for the objects. So it's taking what you told it to place it on top of and doing a line trace on top of those. It's also going to ignore itself in the line trace. And then for every hit of the line trace, it's then going to do another line trace, this time testing visibility. So what it's going to do is it takes the impact point from the first line trace and also the impact normal, because that's a very important part of the process. You want to get the angle at which the line trace hits the object so that you know what angle your prop should be placed at. If it's hitting a 45-degree angle, that prop should ideally be placed as close to that angle as possible so that it makes sense. So after that line trace, we're going to get those hits, and then we're going to break that result into the trace start and the trace end. And if you find the look at rotation from the start to the target, you're going to get our normal rotation on the surface. So this is the part where the creator of this originally created some sort of input where you can change the axes for this. So you can see if I have it set to 0, just place it as it would. However, if I change it to 3, for example, you'll see that none of them are rotated at all, I believe, on the Z-axis. You also have Y and X. So I didn't play around too much with this because it wasn't useful for my purposes, but it's good to know if you want to scatter stuff in orderly straight rows, like for a warehouse or something like that, a store. So the last part of the equation, so to speak, is we're going to get our normal rotation and break that rotation into its components and then assign the relative rotation. And also, if you wanted to, you could add local rotation, which it does here. So because I want the placement to be completely random, sort of prop scattered inside junk, it's not going to have any limitations really, because it can sort of be placed at any angle. So I told it to add local rotation anywhere from nothing to a full 360 degrees in any axis. Last couple of things we have is the scale random, which I demonstrated. We're just setting the relative scale in 3D and adding the max difference size object. So it's just going to pretty much similar to the foliage system, although not as, I didn't lay it out as well or as intuitively, but it's just going to take a max size and a min size. So in this case, let's set it to something like 0.1, then we can get tiny stuff. And then the max size will now be 1.1, or I could make it something very small. And then you can have small junk. The last thing we do is we set the collision for the props that have been scattered. So you can decide if you want them to have no collision, any of your default states. I think I went through this as well, where they would have physics or just query only. Last thing is the world offset, which, as I said, is helpful if you want your props to be sunken into the ground or into other things, as I do. If you want your props to be placed on top of surfaces, straight surfaces, then you can, of course, just disable that. So let's get a cube in here. Although I might have changed this cube to have no collision because I wanted to use it for the fog planes as well. So let's get a sphere, why not? And let's drag this over here. So because I have that Z offset set to -25, the objects are sort of going to be inside the sphere. However, if you change it to 0, then you'll find that minus, the collision size, they should be more closely adhered to the surface. And that's pretty much it. There's quite a different types of variables that I haven't quite got into, but I think those are, probably more advanced things that are definitely not part of the environment artist repertoire. So I think I'll leave it there unless there are any other questions.
Thank you so much, Cairo Goodbrand, for taking the time to share this amazing workshop with us at Beyond Extend. Make sure to check out Cairo's work in the description below. We also want to throw out a big thank you to all of our Patreon supporters. These workshops are only possible because of your dedication and support. If you want to be there live, then head on over to beyondextend.com where you can find access to our community, also environment art resources and other items to help you grow as an environment artist. Stay creative and see you there.